Hello, today's lesson is a continuation of 4.2 Pascal's triangle. So for our opening activity today, what I want you to do is go ahead and try and find the pattern and then complete the next two rows. So go ahead, pause the video, work on that, and then tune back in once you have those next two rows completed. So what they are is 1, 6, 15, 20, 15, 6, and 1. So I'm going to guess that you were able to get the ones on the ends and then probably was able to see 1, 2, 3, 4, 5, add the 6, and then you probably went ahead and did that as well, which is what I would expect. Maybe you struggled with these in inner numbers. So what's really going on here is one is our starter of the row, but then to get the next number in the row, we see 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then again 1 to cap off our row. So to get this next row, I take 1 plus 6 to get 7, 6 plus 15 to get 21, 15 plus 20 to get 35, 20 plus 15 again, 21, 6 plus 15, oh, I messed that up. This is 35. And then here's 21. 6 plus 1 is 7. So we could continue that pattern forever. Today, we're going to our learning targets. I can identify and continue patterns, which is what we just did in the opening activity. And I can use Pascal's triangle to expand binomials. So that's going to be our focus of today. So if you were in class today, one row would be completing each of these, and I would be doing a plus b to the fifth. So for example, row 1 would be doing a plus b to the 0. Row 2 would be working on a plus b to the first. Row 3, a plus b to the second. Row 4, a plus b to the third, so on and so forth. So what I want you to do is do a plus b to the fourth or a plus b to the third. So pause your video, do that, and then tune back in. I am going to do a plus b to the fifth, which is a to the fifth plus 5, a to the fourth times b plus 10, a to the third, b to the second, plus 10, a to the second, b to the third, plus 5, a, b to the fourth, plus, we ran out of room here, plus b to the fifth. So if you were in class, you would notice that it took a long time to do a plus b to the fourth, and I just cranked out a plus b to the fifth pretty quickly, and the students in class are probably going to be like, how in the world did you do that so fast? Well, what I did is I used what's called Pascal's triangle. So that is the triangle that you continued the pattern of in the very first problem for the activity today. So what Pascal's triangle is the coefficients of expanding that binomial. So for example, this would be a plus b to the 0, a plus b to the first, a plus b to the second, so on and so forth. And I'm going to show you how that works here right now. So I'm going to go ahead and use Pascal's triangle to expand a plus b to the third. So if you have Pascal's triangle up, what you want to do first is just write down the coefficients. So using Pascal's triangle, my coefficients are 1. And then I'm going to go ahead and just do plus 3, plus 3, plus 1. So if you're looking at Pascal's triangle, that came from right here, 1, 3, 3, 1. Now I have to look at the exponents. So I take a to the third, b to the 0. So what happens is these exponents have to add to be what our exponents on that binomial is. So now I move on. The a turns into a squared, and b turns into b to the first. 2 plus 1 gives us that 3, and we want to work in descending order of that power. So now a turns into a to the 1, and then b turns into squared, because remember, it always has to add to be that exponent. And then the last one, a to the 0, b to the third. And then we can go ahead and simplify this. So this would simply be a to the third plus 3a squared b plus 3ab squared plus b cubed. Now, if you were in class today, that should be the answer that they got, probably by doing a plus b times a plus b times a plus b, and you realize how much faster using Pascal's triangle was. So if you need extra practice, go ahead and use Pascal's triangle for a plus b to the fourth and a plus b to the second as well. We're going to go ahead and move on here. So again, pause the video, and I want you to expand this binomial using Pascal's triangle. So first, we're going to take a look at the coefficients to the fourth. So this would be to the 0, to the first, to the second, to the third. We're looking at this row right here for to the fourth. So I'm going to go ahead and write all these coefficients out so you can really see what's going on. There. So I just have 1 plus 4 plus 6 plus 4, and then lastly the plus 1. So now I'm going to go ahead and fill in. It would be my x to the fourth and my 3 to the 0, because remember, those coefficients, those exponents need to add to be 4 in this case. Now I would have my x power decreases by 1, so x to the third, and then what do I have to add to that to get to 4? So I would have 3 to the first. Again, decrease my x power by 1, so I have x to the second. My 3, what do I have to add to 2 to get to 4? It's a 2. Then I go to the 4. My x decreases by 1, so that becomes, and then 1 plus what gives me 4? That would be 3 to the third. My x power decreases by 1, so that's just x to the 0. And the 3 to the fourth. Now I'm going to go ahead and clean all that up. Simply x to the fourth. And combine like terms. So here we have 3 and 4x cubed. So that's going to be 12x cubed. 3 squared is 9. And 9 times 6 is 54. My x squared. 3 to the third is 27. Times 4 is going to give me 108. And then x. 3 to the fourth is simply 81, and x to the 0 is 1. So here is that. Now, the next one is a little bit tricky because we are subtracting. So what happens with subtraction is we actually alternate signs. So I'm going to go ahead and color code these again for you so you can see where I'm at here. Okay, and I'm again going to go ahead and write all my coefficients, except for now they're going to have alternating signs. So 1, and then it would be minus 5. That's because we are subtracting in our binomial. Plus 10. And then minus 10. Plus 5. And minus 1 at the end there. Then again, my exponents have to add, in this case, to be 5. So I start with x to the 5th, 7 to the 0. Now I decrease my x by 1, and I have x to the 4th, 7 to the 1. 10 times x to the 3rd, 7 to the 2nd power, minus 10 times x to the 2nd, 7 to the 3rd, plus 5 times x to the 1st, 7 to the 4th, minus 1 times x to the 0, and 7 to the 5th. Now again, go ahead, we have to clean these up, and we get x to the 5th minus, we have negative 5, x to the 4th, 7 to the 1st. 7 to the 1st is just 7, so we take 5 times 7, which is 35, x to the 4th. Here we're looking at 7 squared, which is 49 times 10, so we have plus 490 x cubed minus 7 to the 3rd times 10. That's going to get me 3,430 x squared. Here we're adding, and 7 to the 4th times 5 is going to give me 12,005. And then x is just to the 1st, minus 7 to the 5th, which is 16,807, and then x to the 0 is just 1. So this would be our final answer for x minus 7 to the 5th. Now, could you imagine doing x minus 7, x minus 7, x minus 7, x minus 7, x minus 7? It would take forever. So we can definitely see the advantages of using Pascal's triangle here. Now again, these are just, we have a coefficient on that variable there, so I want you to again pause the video, use Pascal's triangle to try and expand these binomials. So we look at, this would be 0, 1, 2, 3, so we would be looking at this row for the first one. I'm going to go ahead and write my coefficients, 1, and we're adding, so the signs are going to stay the same. And then I go ahead and remember my exponent needs to add to be 3 in this case. So I take my a value, which is 3y, to the 3rd, and then I'm looking at 1 to the 0. Now I have 3y to the 2nd times 1 to the 1st. 3y to the 1st, 1 to the 2nd, and 3y to the 0, 1 to the 3rd. Now I'm going to go ahead and clean this up. So here I have 3y cubed, which is 3 cubed times y cubed. 3 cubed is 27 y cubed, and then 1 to the 0 is just simply 1, plus 3 times 3y squared. 3y squared is 9y squared, so 9y squared times 3 gives me 27y squared. And then 1 to the 1 is just multiplying by 1. Here I have 3y to the 1st, which is just 3y. 3y times 3 is simply 9y. Again, I'm ignoring because 1 to the 2nd is just simply multiplying by 1. Not going to change anything. Here I have 3y to the 0, which is 1. So I have 1 times 1 times 1 to the 3rd, which is just 1. I'm going to switch colors, use blue. So here we're looking for the second one at row 4. So I'm going to go ahead, I'm going to do this down here. 1. Remember, we are subtracting here, so our signs alternate. Minus 4, plus 6, minus 4, plus 1. Okay, so I start with this is my a value, this is my b value. A to the fourth, so 2q to the fourth times 3 to the 0 minus 4 times 2q to the 3, 3 to the 1, 6 times 2q squared times 3 squared. Remember, these are always adding, in this case, to be 4. Now I have minus 4 times 2q to the 1, 3 to the third, and I'm going to scoot this over a little bit, plus 1 times 2q to the 0, and 3 to the 4th. Now again, I figured out those exponents because they are the exponent of a is decreasing each time, and then it needs to add to be 4. So I'm going to clean this up. I have 2q to the 4th. 2 to the 4th gives me 16 times q to the 4th gives me 16 q to the 4th. 3 to the 0 is just 1. Minus 4 times 2q cubed. It's going to give me 96q cubed. Don't forget to multiply by that 3 here, because 3 to the 1 is 3. So what I did to get that 96, I have 4 times 2 cubed q cubed times 3 to get me the 96 q cubed. Plus 6 times 2q squared times 3 squared is going to give me the 216q squared minus 4 2q to the first times 3 cubed is 27 times 8q gives me 216q. And here I have 3 to the 4th times 1, because 2q to the 0 is simply 1. And 3 to the 4th is 81. And that's all for today's lesson. Be sure to complete the Pascal's Triangle worksheet and complete the Pascal's Triangle formative for today's lesson. And as always, email if you have any questions, and we will be happy to answer them. And have a great day.